A regression is nothing but analysis of widely used in statistical tool to establish the relationship between the data points. Simple linear regression is mainly used to estimate the relationship between what? Two quantitative variables. And also what? You can use simple linear regression when you want to know. We have to use the generalized formula, that is what? Plot. So when I call the plot function, so after summarizing, we can visualize the linear regression model into the pictorially. Hello students, welcome to the session 1 of Unit 5 in Statistical Computing and also R Programming. This is the last unit in your NEP syllabus. Let's discuss what are all the contents about the linear regression. This is Asha, the Faculty of Computer Science at Vidhyaashram First Grade Degree College, the Temple of Excellence, MYSURU. Let's discuss what are all the topics here. So in today's session, we can cover about the linear regression and also types of the linear regression. Let's see one by one. So first we want to know what exactly the regression is. A regression is nothing but analysis of widely used in statistical tool to establish the relationship between the data points. So what exactly the relationship? So for example, here you can see A is contains some data and also B is containing some data. So we have to check the relationship between A and B. It is the relationship of numerous, means numerous numbers. And also here you can see a linear regression which contains a slope and also data points. So here you can see these are all the data points. These are all the relationship between what? X and also Y axis. These are all about the linear regression. So let's discuss what are all the types of the linear regression. So the types of linear regression. So linear regression is nothing but the data points distributed along only in linear type. And also in non-linear, you can see this is the non-linear example. The data points will be like this. The data points arranged in a non-linear, means here. So the data points, the name itself says is a non-linear order. Means in a non-linear means the data points arranged in a non-linear way or non-unordered way. This is how the linear regression and also non-linear regression. So in a linear regression, we can see the simple linear regression and also multiple linear regression. The first one is linear regression. A regression, a model that uses a straight line. So here you can see this is the straight line. It uses as a slope to relationship between the variables. We have to find out the relationship between the variables. And also it finds the line best fit through your data by searching for values of regression coefficient, and that minimizes the total error. So mainly regression is one of the application of the machine learning, mainly used for the prediction purpose. So for example, you have the weather data which stored in the previous day or year wise, the weather data will be stored in the database, right? So the data, when we upload that data, so we can predict the future weather forecasting, right? Like how it will be worked. There are mainly two types, as I already told. The first one is simple linear and also multiple linear. So here you can see linear regression model, how it will be looks like. So when you go here, the positive relationship will be looks like, and also this is the dependent variable, this is the independent variable. So if you want to know the simple linear regression, you will get to understand what exactly the graph will, you can understand. So here you can see the simple linear regression is the one of the type of the linear regression. And also simple linear regression is mainly used to estimate the relationship between what? Two quantitative variables. And also what? You can use simple linear regression when you want to know. And also how strongly the relationship is between two variables. Example, relationship between the rainfall and also soil erosion. So here this is the example, and also here you can see the value dependent variable, the certain value of the independent variable, the amount of soil erosion at the certain level of the rain. This is how simple linear regression will be worked. Okay, let's see how the linear regression means simple linear regression will be worked. So this is the formula, the generalized or the standardized formula for the simple linear regression. That is what? Beta naught plus beta 1 x and also what? Error. So here you can see y is the predicted value of the dependent variable. So as I already told, y is completely dependent on x. So based on the x only, y is can predicted. And also B naught is the intercept. So B naught is the intercept, means slope region, and also B1 is the regression coefficient, and also lastly X is the independent variable which completely independent than the Y, and also E is the error. So as I already told, data points like this. For example, the data is distributed in a linear regression. So like this. So what is the difference between these two data, or these two data, or the error between the slope region and also data point? This is how the simple linear regression will be calculated. Example of simple linear regression. So here a step by step. First we have to generate one sample data. The data can be anything. You can take a data frame values, data dot frame. So what do you mean by data frame? In unit 1 you already get to know what exactly the data frame. So data frame, the data will be arranged according to the frame wise, that is the tabular format, right? It is also one of the data structure used in R. And also it generates a sample data. First we have to create one sample data. For regression, we have to generate a predicted value based on previous values only, right? So we have to regress, or we have to predict the present value based on the past values, then only we can predict. And also fit the model using what? LM. So LM is nothing but what? A linear model. This is also inbuilt function providing by the R. And also summarize the model, review the results. After you can get to know summary. Summary is also one of the function, so which summarizes the model after predicting. And also plot. We have to use the generalized formula, that is what? Plot. So when I call the plot function, so after summarizing we can visualize the linear regression model into the pictorially. So here you can see one example how the linear regression, simple linear regression will be worked. And also we have to set the seed value as a 0. Why? Because the starting point of seed value is at 0. Because we have to initiate the model in beginning. So means we have to initiate the model in begin. So that's why 0 is set as a seed. And also generate the sample data. So use the function called RUnif. So you already know in probability distribution, R is one of the function, means R uniform distribution. So and also Q uniform distribution. These are all some set of the functions, right? So that's why. So RUnif, assign a 2 into unif of independent variable. And also Y is equal to 4 plus 3 into X, R norm. Means I used a normalized distribution. That is what? 100. This is a dependent variable. So as I already told, X is, we already know, that is a independent variable. Y is dependent on what? X. So that's why 4 plus 3 into X. Got it now? This is how the data will be given. So after that, create a data frame. For that we need a one variable called data. So call the data frame. So we already know the X and Y value, assign here. Whatever the X and Y value, assign using the data frame. The data will be arranged in a frame wise now. After that, call the linear regression model, that is LM. And now, so your data, so call the here Y is equal to X. So what do you mean by this? Is what? A tilde expression. This is logically equal to Y. Why? Because Y is completely dependent on what? X. So that's why Y and X also same, means is logically equal. And also call data, whatever the data after processing the data frame function, the data will be. So data is equal to data is nothing but what? A data is equal to data is equal. And also now summarize the model after that. So we already get to know what exactly the steps of creating a simple linear regression, right? These are all the steps. So first, create one data. We have to difference between the what? We have to define the X and Y. After that, create a data from, means we have to create one sample data. After that, use the model, that is LM. And after that, summarize the model using what? Summary function. These are all functions. So that's why case sensitive means small cases. And also after that you have to plot the data visual representation, right? So that's why call the plot function. And also data $x. Data $x in the sense data, in the data we have X and also what? Y. But I need only X. So that's why dollar is the address of X in a data. And also $y. And also main. Main means heading of the graph. What is simple linear regression? And also X lab means X label. X label in the sense here is the graph. This is x-axis, this is y-axis, right? So we have to given the label as what? Independent variable. So that's why independent variable. And also here dependent variable. That is what Y lab dependent variable. And lastly PCH. So we know the linear regression of the plot, right? So this is the data points when the linear regression model uses, right? So that's why the data points can, what PCH is given 19. So 19 in the sense PCH is nothing but what? Plots character or points character. So we can plot like this dot and also whole and also what? Rectangle and also round with a plus mark. These are all some PCH values. So when you give the 19, it will generate the graph, and also what color of the graph is blue, means blue line and also dots in a blue. So and lastly a AB line model color is equal to red and also LWD is equal to means width. Length of the width is 2 and add the regression line now. So here you can see a multiple linear regression. A multiple linear regression is nothing but what? Multiple linear regression is nothing but a statistical model that relationship between one dependent variable and two or more independent variable. So as I already told, so here you can see x, x1, b0, b1, x1 and also b0. This is what? A simple linear regression, right? So multiple linear regression is nothing but y is equal to b0 plus b1 x1 plus b2 x2 means beta 2 x2 up to what? bn xn. So this is how the definition says a relationship between one dependent variable. One dependent variable is nothing but y, and also two or more independent variable means what? X. So x1 comma x2, these are all the independent variables. So dependent variable is only one, that is y. So the goal is to find the best fitting linear regression that describes the how independent variable influence the dependent values. And also the general formula, here you can see the general formula b0 plus b1 x1 plus b2 x2 and also up to what? bn xn, and lastly we have to find out the variables reference, that is the variable error. And also here you can see a multiple linear regression, how it will be looks like. A multiple linear regression. So here you can see the data values like this, and also the P. The P is number of predictions and also E is the error. This is how multiple linear regression will be looks like. And also let's see the difference between simple and also multiple linear regression. So and also the main difference between the simple and also linear regression is the number of independent variable, and also using a single independent variable it establishes the relationship between two variables, that is the simple, and come to the uses two or more independent variable to estimate the relationship between what? Dependent variable. And also for example predicted based on what? A square footage and age of the building, that is what? Multiple linear regression. And also here you can see a single predictor means this is the example for simple linear regression, means only x is 1 and also y is predicted based on what? X. And also here you can see there are too many independent variables, it will be dependent on y. Y is dependent on what? X. So that's why these are all the multiple predictors, means multiple linear regression. This is how the difference between the single and also multiple linear regression. Got it now? Thank you.